Hello and welcome to Noel's Retro Lab. Today we're going to go back yet again to the TI-99 foray. We left it outputting a monochrome image, so at least it was working. Today we're going to try to get the full color out of it and run some more tests. Last time I got some static RAM to try to fix a faulty RAM, but it didn't seem to work until I figured out that I was using the wrong ROM data in the wrong slot. Once I fixed that, everything worked fine, and we managed to get some black and white image out of the TI-99. And now let's try to get a full color image. So I'm thinking that one thing worth trying is just seeing if the TV will accept the component signal the way it is here. So this is the luminance, and this is the luminance minus red and luminance minus blue. So we can hook up two other RCA jacks and then trying it with the same cable. And if it doesn't work, then we can move on to plan B of trying to get RGB out of the board. All right, there's our big mess of cables. And let me just say it again. This is temporary. I would never do this like this permanently. I just want to see if we can get some color image now out of the board the way it is. Okay, let's try it. And yeah, I'm not too surprised. So this is exactly what happened to me when I was testing those fake chips from China from a few episodes ago. I was able to get luminance displaying on this TV just fine, but when I hooked up all three components, then it wouldn't even recognize it as a signal. So I need to dig in a little bit more and find out what's the difference between the component signal outputted by the board and what the TV expects. But it seems that for now, this is not the right way to go. Since I expected this could probably happen, assuming we managed to get the board working, I prepared from the beginning another alternative, which is to generate an RGB signal from this board. And for that, I had a friend send me over this PCB. And yes, this is tiny. Check that out. This is some of the smaller SMD soldering that I will have ever done. So this is definitely going to be a challenge. This board comes from a project created by Citrus 3000 PSI. It takes the component inputs from the VDP, Y, U, and V and generates RG and B signals. This particular PCB was sent to me by my friend Quickie, thank you very much, along with the SMD components in the form of a kit all ready to solder. Once you download the Gerber files, you can create your own PCBs through an online service like PCBWay, which are the kind sponsors of this episode. You can go to PCBWay.com, click on Instant Quote, upload the Gerber files already zipped, and you're ready to order them. It only takes a couple of clicks and you get to support this episode's sponsor. So how exactly does this magic conversion from YUV to RGB work? YUV is really Y, which is luminance, blue minus Y, and red minus Y. At a high level, we just need to add B minus Y plus Y, and we get B, or blue, out of this. And same thing with red. If we add red minus Y to Y, we get red. Then to get green, we subtract the two signals we got from Y as well. And there we have RG and B very roughly. There's some factors that are missing to get in properly. And then what we're completely missing in this picture is generating the sync signal, which is also done from luminance. And then honestly, sometimes you can just use luminance straight and that works as a sync signal. And why does this have to be so tiny? At the beginning, I didn't get it either until I realized that this is intended to be assembled right here under the VDP, and those are the inputs right there. Like, I don't know if it's like this or the other way around. Obviously, I need to check that. But the idea is that it sits flush up against the board and it gets the inputs right there. So it's a really cool idea if I manage to do that kind of soldering, which is going to be a big challenge. All right, let's try to build this. And yeah, this is scarily tiny. Especially, it's not even just the tiny, it's how compact it is. Once you solder something there, it's very difficult to solder something next to it. So, I don't know. We'll see. It's going to be an interesting exercise anyway. And to make things more difficult, it turns out this PCB has a small problem. It's just been fixed in a new revision. But actually, I'm supposed to cut a track right around here and solder a capacitor connecting those two pins. So let's start with that. And I was thinking, I can't zoom in anymore. anymore. with this camera, but actually I can do the old-fashioned magnifying glass, and I think it looks okay. Gives you a better idea of what I see from here. So this is the track that I'm supposed to cut right there. For now, I just want to cut it, make sure there's no continuity. And then I'll just start building the capacitors, which are going to, and the resistors. I'll leave the integrated circuits for last. So there you go. I cut that track over there just with a small screwdriver, and I checked that there's no continuity between there and there. And I just could not do this on camera, not between the magnifying glass and the camera being in the way, and it's difficult enough as it is. So I will start with the soldering now. Since I expect the soldering to be so packed and crowded, I'm going to use definitely a very fine tip, but also a curved one. I don't normally use this one, but I think it may help me reach in those pads better. So we'll start with this. If not, I'll switch to the another thin one, but straight. And as usual, let's start by cleaning everything with some isopropyl alcohol. So I'm putting this here as an example of how things were not working correctly at the beginning. This kind of flux was not working very well, and as you can see, the solder is just not sticking to the pads very well. It's not even sticking to the capacitor for that matter. Okay, that was better, but this is not looking good. So I've now changed to use paste flux, and this one works so much better. So let's do another one. So put some of that in the pad. Yeah, look at that. What a difference. That melted much better, and you can tell it surrounded the resistor. Of course, I left it a little crooked, so I need to readjust it. And yeah, that's much better now. So this is not perfect. I'm definitely not an expert SMD soldering person, but I've definitely gotten better even as I soldered this many resistors and capacitors. So, okay, on to the integrated circuits, and then we'll have to do the little patch over there. The integrated circuits are very similar. We first apply a lot of that paste flux. Then we add some solder to one of the corners. Place the IC on top. And melt that solder to leave it in place. We may need to adjust it a little bit so the pins of the IC are touching the pads, and here they didn't get it completely right, but it's good enough. And then we just apply solder to all the pins to make sure that it has good connections everywhere. And this is what it looks like with all the integrated circuits in there as well. So all we have to do is to add that little fix in there. There's the fix. So now I need to double check every resistor and capacitor and make sure they're what they're supposed to be. And then we can finally test it. So that wasn't the prettiest SMD soldering job that I've ever done. I was definitely out of practice soldering things that small. But I checked it over and there seem to be no shorts and all the right components are in the right places. So let's go ahead and test it. This is intended to hook up directly to the back of the VDP. It turns out there's only 5 connections, but there's 6 solder points. So there's RGB. Well, no, sorry, there's not RGB. If it was RGB, we wouldn't need to do this. There's Y, blue minus Y, and red minus Y. And there is 5 volts and ground. The 6th one, which I believe is this one, is just for support and making sure that stays tightly there. So what I'm going to do now actually is I am not going to solder it there just because it would be a lot easier for debugging this and finding any problems to have it separate. So I'm just going to run some cables from those 5 points to the board. So we'll just have it sitting side by side. And then this is the output over here. So over here we have blue, red, green, no idea why they have that order, sync, ground, and 5 volts. And so what we need is an RGB cable in this case, it's going to go to SCART because that's the easiest way to connect through RGB to the TVs that I have. And I was looking at it, and actually I have such a cable with a 6-pin DIN connector as well. This is for an Amstrad CPC. And obviously the pin assignments are different, but since we are going to change completely the pinout, since we're going to assign R, G, and B in different ways than this is outputting them right now. I'm going to see if we can actually rewire things. So I don't even have to make a change to the cable since we know this is working. It will be more convenient. But for now, I'm just going to connect this separately, and I'm not even going to go through the TI-99 connector. We're just going to connect this output directly to this connector in the same form as the Amstrad, and that way we minimize any unknowns.
We do this as usual. We first add some solder to each of the pads, and then we just solder the cables in place very easily.
I just realized that a much better idea than trying to hook up those cables directly to this connector is to use a female DIN 6 connector. So we can connect those here, and then this will neatly plug into here. Once we get everything working, we'll desolder these and hook them up to the TI-99 board instead.
Opening up these connectors is always a challenge, at least for me. It's tricky to push it just right and then being able to separate the two, but there we go, that's better.
So one very important thing about this is that we're dealing with the female connector, so we need to be very aware of what we're seeing things in the schematics from here or from here, because the images are mirrored. So since we're going to solder from here, but this is a female connector, we're going to need to flip it. So it's going to be RGB sync and ground, I think. Of course, as usual, I forgot to put the plastic sleeve before I soldered everything, but fortunately this is just a temporary connection, so we'll manage just as it is. Okay, so we just need to hold this together, so I guess I can reuse this tape from before. Just like that. It's just a quick temporary fix to test things. Next, I'm going to solder these cables temporarily on the bottom of the VTP. And again, this is a little tricky because this is mirrored from the usual layout. So I'm having this on the side, but I'm trying to remember to flip them. And if there's any doubt, we can always go back to the position this is supposed to go, and that I realize goes in that pin, which then makes those the component signals, 5 volts and ground. This is the SCART cable going to the TV. This is the Amstrad one, unchanged. And let's connect it to our connector and see what happens. Okay, let's give it a try. Yes. Oh, yes. Beautiful, beautiful. And this startup screen is great too, because you can check to see if the colors are correct, and they look correct to me from what I remember. So yeah, and it's so sharp and clear. So awesome. We got color RGB coming out of the TI-99 4A. Yay! Unfortunately, we're not done. We still need to put this back in the board and then hook it up to the connector so we don't have to be doing this every time. So let's try doing that. Let's start by detaching our RGB board from all the cables, and then we'll put it in the backside. I think that in order to fit these eyelets correctly on those pins, I'm going to remove the solder with a suction pump. So you can see this way how flush it is against the board. It's very nice. That's the huge benefit of using those SMD components. I actually just realized that before plugging it in and trying out the image on the TV, I actually tested the signals on the output in here, and I totally forgot to take a video of that, and I thought it was interesting enough. So let's go ahead and do it now, and that way we also check that it's still working correctly after connecting it to the board and that these input signals are all correct. So I'm going to turn it on, and we're going to look at, that's the G signal. Yep, that looks totally fine. And then those two should be pretty much the same. That's R and blue. And then this one threw me off for a loop at first. This is the sync signal, and it's tiny. This is 0.2 volts or something like that. And I was convinced there was something wrong. It turns out this is correct. And if you look at the schematics, the sync signal actually goes through a voltage divider, pretty heavy one, to drop it to 10%. But I suppose this is what it's expected on the TV input, because obviously that worked great. So yeah, that's fine. And then we have ground and 5 volts. So it's good to see the signals, and it's good to see that it's working after connecting it to the board.
As a final step, we need to figure out how to connect the RGB out signal to the video connector of the TI-99 4A. So this is the schematic of the video out, and actually it turns out this is wrong. So the pin out is more like this, and what we really want is this. We want our RGB, sync, ground, and audio. Now, fortunately, ground and audio are the same, so we don't have to muck around with those two. And we can connect the other 4 signals, but we need to make sure we detach them from the current circuit they're attached to. Otherwise, the signals will get mixed together and typically bad things happen. So we need to unplug the circuit in a few places, and it's pretty straightforward. We don't have to cut any tracks or make anything irreversible. We also need to remember to remove that little capacitor right there for the red signal.
For pin 1, I'm going to pull out this coil, this inductor. Like that. We'll figure out a way of putting some insulation so it doesn't accidentally touch anything. This one should do pin 2. And then pins 3 and 4 are those. Okay, everything is disconnected now. So for those, I think I'm just going to put a little bit of electrical tape to prevent it from making contact with anything. They're pretty stiff, so I don't think they will. But that will make sure it doesn't. And same thing with the resistor. I could take it out completely, but I hate to do that because someday somebody might want to put it back the way it was before. This is invasive enough what we're doing. I want to minimize any changes. Okay, so that's not the prettiest job, but it will be fine. These are the cables that I'm going to use to connect the RGB board to the video connector on the underside of the board. And I just added this heat shrink wrapping just to keep it together. So I'm just going to heat it up a little bit, and then we'll solder everything in place. There you go, that's much neater. And now all we have left to do is to solder this from there to there. Notice that in this case, there's no need to hook up ground or 5 volts because, well, ground we already have at the connector, and 5 volts we don't need in this particular case. And that's it. That should be it. Okay, so now we're just connected through the video connector and nothing else. And when we turn it on, there we go. Perfect. So this is exactly how we want it to work. So that's fantastic. So now we can put everything back in the case and make sure everything fits, and we can move on to something else now that we know that this is finally working. There was actually one last thing that I wanted to do that I said I would do once we got things working, and it's to check if both of those RAM chips were faulty or not. So those are the ones with our question marks. So I'm going to this is off, I'm going to pop one off and put one of those. It doesn't matter which one, they should be the same. And let's try that. Okay, that one was fine. So I imagine it's this one that is faulty, but let's try it anyway. It would be kind of horrible if it works, because then I would have no idea what it is. So no, this should definitely fail. Yep. Oh, and that's the sound that we were hearing that we never actually heard it. We saw it in the oscilloscope, so perfect. That gives us some closure in that sound wave that we were never able to actually hear. So perfect. It was that one that was bad. So one potential problem of putting this board with the new PCB back inside the case is that it has this RF shielding. Now, normally a lot of RF shieldings like the Commodore 64, I just throw them away because they're just like a cardboard painted with some silvery paint. And all they do is keep the temperature up inside the board, and really today they're not needed very much. But this is a little different. This has some structure to it and has some screws, and this attaches to the case, so I really don't want to get rid of this one. At first I thought that I was going to have to put some plastic here because this is just plain metal, and I even tested it and it is conductive. Then I started wondering, but wait, wouldn't the bottom of the board itself be touching this and be a problem? And then it turns out that no, obviously that is not the case, because it's designed so that the board sits on top of the RF shielding like this. So it's not touching anything. There's even more of a gap even than we need. So this is great. It serves our purposes perfectly, and we don't have to add any plastic or anything. We can just assemble it straight up. And also, before putting this completely away, I'm going to put some heat sinks right on the VDP. They're not strictly necessary, but it's a nice thing to have. He came with one, and I think these are going to be better than the one he came with. So that should keep it nice and cooler.
And for the true final test, let's bring it over to my retro corner with the CRT TV. Yeah, beautiful colors. And fortunately, the keyboard works fine, and we can get to basic. Awesome.
So there you go. The TI-99 4A is outputting beautiful RGB video out. So that's a great step from how it was last week, and certainly how it was at the very beginning, which wasn't even working. But I'm still not done though. I actually wanted to explore what the TI-99 can do now that we have it finally working, and look a little bit more closely at that weird architecture that it has. We know that it's a mix of 16-bit and 8-bit, but I wanted to look more in detail and understand exactly what that means, because there are some very interesting architectural decisions made inside of the design of these computers. So what I'll do is I'll leave that for another episode, and that will also give me the time to properly focus in some of the accessories and some of the details of this very fascinating computer. Anyway, I hope you enjoyed the episode. If so, please give it a thumbs up and subscribe to the channel. Until next video, see you then.
If you enjoyed this video, please consider supporting Noel's RetroLab on Patreon or joining the membership on YouTube. Not only is that the best way to support the channel and allow me to continue making more videos, but you also get some extra perks like early access ad-free videos and more. Thanks again to all the supporters. See you next time.